Now, in this next problem, we're looking at a raffle with various types of prizes that you can win. One $1,000 prize, five $100 prizes, and 20 $10 prizes. We want to know what's the expected gain on a $10 ticket. So, like we've done in the previous problems, we first have to figure out what are the scenarios where a gain or a loss will occur. Well, there's the $1,000 prize, so we need to figure out the probability of that. There's a $100 prize, there is a $10 prize, or there's the situation where you win no prize. So what's the probability of winning $1,000 in this raffle? Well, there's one of the winning tickets that's going to win $1,000 out of the 200 that it says are sold. So that's a 1 out of 200. Now, how much do you gain if you win that ticket? Well, first you have to realize that you spent $10 on the ticket itself, and then you get $1,000 back. So your gain on that situation is actually only $990, not a full 1,000, because 10 of the dollars that you get back are you can think of as are the $10 that you already put in for the ticket. The $100 prizes, there's 5 of them out of the 200 tickets sold. And similarly, we got to think of a gain here as only being $90 because you spent $10 on your ticket. The $10 prizes, there's 20 of them out of the 200 tickets sold, and that is a gain of 0 because you already spent $10. So you're basically getting your money back, and you're kind of breaking even if you win one of these $10 prizes. Now the no prize tickets, well, if we take out the 20 $10 winners, the 5 $100 winners, and the one $1,000 winner, that leaves 174 tickets that win nothing, so 174 out of 200. And in this case, it's a loss of $10 because you spent $10 on a ticket and you didn't get anything out of it. So if we're going to look at our expected gain for a ticket, we're going to take the $990 that we gained by winning the grand prize and multiply it by that probability of 1 over 200 plus the $90 we gain if we win $100 times that probability of 5 over 200 plus a $0 gain times the probability of 20 over 200 plus a loss of $10 times the probability of 174 out of 200. And so now the way this works out is this math gives us about a $4.95 gain. This is about a $2.25 gain. Of course, this breaks down to nothing because we're multiplying by 0. And this is a loss of about $8.70. All told, what you can expect to have happen here is a loss of $1.50 per ticket. Now in this next problem, we have kind of an interesting game where you're basically flipping a coin. Player A flips a coin, player B flips a coin. Every time it lands on heads, player A gets a point. Every time it lands on tails, player B gets a point. So let's just kind of write that out. A, they want heads. B, they want tails. The first person to reach 3 points wins $100. If A currently has 2 points, so 2 points for A, and B has 1 point, from that point forward, what is A's expected gain? So we got to think, well, what could happen here? What could happen? What are the possible outcomes that could occur in this game where A wins? So A wins if what kinds of things happen? Well, A wins if the next flip is a head. Or A wins if the next flip is a tails. That would make it 2-2, and then there's a head after that because then they would have 3 points before B got 3 points. So what is the probability that the next flip is a head? Well, it's 1 out of 2, right? In that case, A gains $100. What's the probability that it goes tails then heads? Well, it's a 1/2 chance that the next flip is a tails, and then another 1/2 chance that the next flip is a heads. So that's a 1 out of 4. And in that case, A gains $100. We don't have to think about them losing anything, so I don't have to think about the scenario of B winning because we're going to assume that it didn't cost anything to join this game. I guess I should have said that right at the outset of the problem. It didn't cost anything to join this game. So we don't have to consider the situation where B would actually win because A doesn't necessarily lose anything if that happens. We just got to think, well, how could A win? And that would be these two scenarios. So now if we're going to do our expected gain or expected value formula, we're going to take the $100 that they would gain in the first scenario times the probability of it happening, plus they still stand to gain $100 if this happens, and it has a 1/4 chance of happening. So that's 50 plus 25. So at this point in the game, A has an expected value of $75. Now in the next problem, we put a little wrinkle in there. We said, well, what if, same game, but now they're playing to 5 points to win $100, right? First to 5 wins $100. You have 4 points, and player B has 1 point. You offer player B, you say, okay, I'll give you $5 if you walk away, and then I win the $100. Right? So you kind of basically be gaining $95 in that situation. You say, I'll pay you $5, player B. You walk away, I get the $100. Should player B take the deal or not? So how would we, in order to kind of figure out whether player B should take the deal, we need to figure out what is player B's expected value at this point in the game. What is his expected gain at this point in the game, right? Well, B would only win, they would only stand to gain any money if what happens? Well, the only way that they can gain money is if there's 4 tails in a row, right? Because B wins by getting tail. They get points by getting tails. You're already at 4. If you get another heads, you win. You're at 5. So B needs tails, 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 tails to be the next 4 flips. They need to get tails on each of the next 4 flips. So they would get to 5 points before you got to 4 points. Well, the probability of that happening is 1/2 times 1/2 times 1/2 times 1/2, right? It's a 1/2 chance for each one of these flips to end up as tails. So that turns into a probability of 1/16. Now their expected value, their expected gain, would be $100 because if this happens, that B gains $100. So that's a $100 expected gain, or a $100 gain for this outcome, with a 1/16 chance of it happening, which works out to be an expected gain of $6.25. So what does that mean? Well, what that means is that B should not take the deal. Why? Well, and I'm not going to write all this out, but the B should not take the deal because by taking the deal, they only stand to gain $5. But by playing the game out, their expected gain would be more than that, $6.25. So that's why they should not take the deal in this case.